It is Wednesday, April 6th, 2022, and it's 6:15 p.m., and you are at a Wausau Waterworks Commission meeting. Welcome, everybody. The first item on our agenda is to approve the minutes for the March 1st and March 8th, 2022 meetings. I would entertain a motion. I have a motion by Herbst and a second by Jean. Anything commission members would like to say? I'm not seeing any. So all of those in favor of approving the minutes for the March 1st and March 8th meetings can signify by saying aye. Aye.
Aye.
Any opposed? Okay, that passes. Next up, director's report. I will toss it over to you, Mr. Lindman.
Yeah, thanks, Mayor. Quite a few items, some just kind of carried over from the last couple months as well as updates, but if commissioners have any questions on any specific items or progress on anything, please let us know. Try to answer any questions you might have.
I see Robinson's screen lighting up. I think he's ready to ask a question or say something.
Hey, John.
Good. So I am not joining you in person, but I got some sort of bug, so I figured
We
it
don't
was
want
safer
it.
to be here. So on this Eric, on the solar array project, when will the geotechnical work be done?
All I can say right now is as soon as we can get a machine in there to start digging some test pits. I don't have a specific time, but it should be early this spring, John.
Okay.
And then a question relative to the well 3. And the question is, how is, they want us to continue to treat that. Is the hope long-term to shut that down? Short-term, long-term?
Well, short term would be great, but the consent decree, and we'll have to work with the EPA on that with our consultant. So, ideally, we'd like to just shut it down. Yes.
So is PFAS and the presence of PFAS in the well exacerbating that problem from a regulatory perspective?
Yeah, that's really kind of what steered the direction that they did not want that being discharged to the river. No.
So have we approached them about shutting it down if they don't want the discharge to the river?
Yeah,
If they don't want it to be a point source, can we accelerate the timeline for shutting that well down? And using the argument that we don't want to have a point source discharge from that well?
Yes, and so that went back to our consultant, and they're working with the EPA to get a meeting set up with them and trying to determine what the EPA's timeline would be for us to shut that down at this point in time.
So, I think we should try to, craft the talking points for shutting that down in light of the concentrations in there. And I'll give you a call and we can talk about that.
Okay.
Ms. Herbst. Do you want to flip on your mic for us? Thank you.
Mouth.
Yeah, well, public access can't hear that far.
And I don't want to disturb Pepper. Just curious to know what the update on the water pitchers and the bottled water. An update.
Sure. So we got our first shipment of pitchers. I don't know where we are with water, but we've been going through water at a steady clip. We've handed out a bunch of them. We're going through a list so that we can control how many people show up at the same time. So we've been notifying people by email, by phone, when their pitcher is ready to pick up. And we've had folks at the close to the drinking water facility, current one, passing them out. So I don't know how many we've gone through yet, but I do know that I think we had 1,500 delivered, and that we're getting through, and then we're gonna have another shipment. I don't know how many off the top of my head.
Did we get a timeline on delivery for the next shipments? Yeah.
No timeline. They came relatively fast last time after we went through with some of the procurement process and with the POs and stuff. But there's another 2,700 on order, so that would be 4,200 total.
Another comment that I have concerning the bottled water. A big concern that I have, and I have heard this, that one lady was bragging about the fact that she went and ended up with 10 cases of water. Here we regulate the pitchers, which is great. That's the way it should be done because they're costly. But the fact that people can come and just load up, I don't know how many people showed up, but 10 cases that one person picked up is a lot of water. And I think that's wrong. I also understand that they can pick up water. Is it the Hmong Association that all you have to do is stop in and they will give water to you as well? Are pitchers involved there as well?
We're working with them because there's a barrier with the language, and we saw that when we were handing out pitchers this week. I was down there helping out, and there was definitely a barrier with some folks, so we want to make sure that we're accessible. So, yep.
Perfect, thank you.
I can't tell you about the pallets of water. Are you saying that she came to us and she got 10 cases of water? Because it could be that she went to other places too, but I don't know.
That wasn't clarified to
Okay.
me, except for the fact that she received 10 cases of water, and to me, that's depriving 9 other people from getting water.
Yeah, when I was down there, they weren't handing out 10 cases of water at a time to anybody.
I didn't think.
So, okay. Mr. Jean.
I just want, John, I concur with your comments regarding CW3. And I just want everybody to know, PFAS was not part of the consent decree, so and I would think the only people that would have authority on that would be the DNR, not the EPA. But of course, we have to satisfy the consent decree to be able to shut that well down. I worked the polls yesterday, and
Thank
we
you.
ran out of ballots, but it wasn't the end of the world. We were able to solve that real quickly with the other unit. That has nothing to do with the meeting, but there was a lot of discussion about, a lot of people asked me questions about the PFAS and et cetera, but one lady, and I think she used to work for the health department, said, why didn't somebody come up with the bright idea that they blend some of their city water with bottled water to lower the PFAS? And I said, well, I'll pass that on. If people want to do that, it's not, I don't think that's the worst thing in the world. It'll reduce that down below if everybody's target is the 20. I think most prefer not to have any, but, and I don't disagree with that. I think I have another question, but I have to go back through the notes here if there's going to be some other discussion.
Sure. Any other comments or questions on the director's report? Mr. Robinson.
So Eric, we continue to have the employment issues and, are we looking at efforts to reprioritize work and potentially call on others to give us a hand? I'm thinking particularly, we started looking, one of the reasons we didn't get at some of the work was snow plowing and other winter-related activities. Are there some opportunities for us to work with other departments to get some help so that we don't get so far behind on some of our maintenance and other activities? And the second thing would be are we looking at innovative ways relative to advertising for like our openings, in this case, the summer aid position, looking at non-traditional methods?
Yeah, really relying on HR. I know that they've been looking at some different strategies for advertising and doing different things. I think, we're staffing basically citywide has been difficult and challenging. And so, I think right now we've reduced qualifications on some of our job descriptions. I think right now, if things don't turn around, we start getting some applications for some of these positions. I think we're going to just be down to the point where we have to raise starting wages to attract more people. I mean, that's about where we're at. I mean, we can't make any more edits to our job descriptions or anything like that to try to reduce quality. I mean, we're basically down to a high school education and very little but more preferred experience rather than required. So.
Okay.
The second part of that question, are we looking at reprioritizing work to focus in on maintenance?
Yeah, I mean, our at the water and wastewater, I mean, I think they're constantly juggling, trying to figure out priorities. And I think right now, a lot of it is, as issues come up, they're addressing them. And a lot of the preventive stuff is not happening, so. But Scott, Ben, you can feel free to, if I'm.
Mr. Jean.
I talked to Ben briefly about the industrial park force main cleaning, and I understand it started yesterday or day before, but I'm not sure. But how many days do you anticipate they'd be working on that?
They'll probably run into next week, middle of next week before they're finished. They'll run several pigs through the force main to clean all the collected grease that is collected over the years, so it takes time.
Thank you.
Yes, Mr. Force.
I apologize for being a few minutes late.
We'll forgive you.
Thank you. On the solar project, Eric, if I read point 5 correctly, the engineering firm has been working on landscape renderings, and you did share those with me. But then later on, it says, staff will also be meeting with the neighborhood group over the next couple of months to discuss the proposed solar array options and possible landscape renderings. The neighborhood group has not been meeting in person and is expected to begin meeting in-person meetings this spring. Wouldn't it make more sense to have the meetings with the neighborhood and then go to the drawings? It seemed to me at the meeting where we discussed this back in December that group was going to meet, and some joint discussions between the Waterworks Commission and the neighborhood were going to take place, and then recommendations from those meetings were going to be incorporated into a landscape plan. Maybe I'm reading it wrong.
Yeah, when we came away from the public information meetings and the feedback, Jim, what we got was that the community wanted to see, some ideas on what things would look like. And so the idea would be to try to present them with more information on what, the solar array would look like, concepts from plan and profile and from their homes. And then if they felt like, other things could be looked at. I think some of the challenges there, we're trying to explain to them, what a berm would look like or what plants and stuff would look like. And I think that they wanted to see that before we sat down with them. That was my interpretation. So, and I haven't reached out to the neighborhood group probably for a few weeks with other things going on. So I don't have a meeting set up with them yet.
Any other? Yes, Mr. Jean.
Would it make some sense that we kind of put that on hold for a while until we decide if we need any extra space for adding on to the new plant? I don't know that we are at that point of knowing that information, because that could change the landscape for solar panels out there, I would think.
Maybe we can agendize that as a discussion topic for a future meeting.
Okay.
Cool. Any other comments on the director's report? All right, we're going to move on. So next up, we have our presentations from engineering and consulting firms regarding expertise related to PFAS treatment and removal from drinking water systems. This is why your packets are so enormous. Thank you for everyone that submitted their stuff. So I'm just going to go down the list. We're going to start with CDM Smith. Welcome.
Good evening, everybody. Thank you for this opportunity to present our qualifications to the commission and to the public. We're looking forward to working with the elected officials and with the staff as you kind of wind your way through your PFAS design journey. My name is Matt Bednarski. I'm a senior environmental engineer and a client service leader with CDM Smith. I always have to sort of emphasize the M because there's another company in Wisconsin that sounds very similar that we shouldn't be confused with. I have some colleagues with me today, one here in person and two on the WebEx call, and I'll introduce them as we get to that part of the presentation. Oh, boy.
We tried to change the batteries to see if that would help.
No, I think I hit the wrong. Oh.
Try it.
Yeah, it just keeps,
So instead of the middle button, use the.
You're
little arrow.
Go to the right.
no, which one is it? Oh, okay, all right. Okay. So I just wanted to lay the groundwork for what we're going to talk about this evening. We're going to talk about our team, who we are, and who CDM Smith is. We're going to talk about our PFAS leadership and our qualifications from across the country and close to home. We're going to talk about relevant PFAS experience to Wausau, and that means relevant means that works with your water chemistry, and it works with some of the studies that are ongoing with the city. And we'll get into a conclusion and a question and answer session at the end. Oh, boy. Yeah, it just keeps pulling up that. Can you go back one slide for me? There's. Thank you. Thank you. So on this chart, this is our project team that we propose for this project in guiding the city through PFAS design. There are 4 people with me today, but there are a few others that I'll touch on as well. So with me here in the room is Mark White. Mark is our national leader in water treatment. And the great thing for me is that because I work and live in Wisconsin, so does Mark. So I have him at my fingertips, and he's our national leader for this. On the virtual call is our lead lab technician, Zoom Win. Zoom leads our lab efforts for all things to do with water quality and water chemistry, and has spent quite a bit of time working on PFAS projects. And also on the call is Al LeBlanc. Al has led and been a designer for many of our dozens of PFAS treatment projects over the years. What am I doing?
This is actually the test here.
I'm eating away at that 15 minutes here. You can. 2022 is CDM Smith's 75th anniversary, and we grew up as a water firm working in water treatment, formed in 1947, and doing that from day one. And we still do that. That makes up a big portion of our business today even. We've added many other things, but water is in our at our core and in our DNA. The one back, please. I just wanted to point out that we have more than 100 staff in our region working on these projects, and that we've worked in dozens of communities in the Midwest and around the Great Lakes, including in Wausau. So we're working in Wausau on your lead service line replacement program. We are a partner to Clark Dietz on that, who is on our team for this. And we are working on your corrosion control treatment study, which is integrally important to the PFAS study as well, as we need to make those water chemistries work together. Next, please. Across the country, CDM Smith has almost 200 different PFAS projects, either water treatment or environmental projects, and we started working on these kinds of projects in 2007. So prior to when it became an issue for drinking water utilities, it was more of an issue for our industrial clients across the country, and that's when we started working on these issues. New England seems to be the heart of the starting point for the drinking water portion of this, and that is where our company is based. We're based in Boston, and many of the projects that we have that you see on the map emanate there in New England. But as you can see, as states are creating those regulations, as we move west, we are working with those in those states as well. So I'm going to turn it to Mark to go over some of the projects that we've worked on.
All right, thank you.
Yeah, I'm just going to go through the next couple of slides, kind of present some of our experience and some projects that are similar to what you're experiencing. First project here, it's in Massachusetts, and as Matt said, Massachusetts was one of the first states to come forward with regulating PFAS, and still has some of the most stringent PFAS regulations in the country. And so in this project here in 2016, they found PFAS at elevated levels, 10 different compounds, over 300 parts per trillion. And so CDM Smith was called in. We came out, kind of helped their facilities right next to an airport, and so we identified where the source was coming from, worked with them we took water samples and sent it to our laboratory, which our treatability laboratory. So they were able to run kind of side by side, small scale rapid column tests in such a way they could very quickly look at 2 or 3 different PFAS, or 2 or 3 different activated carbons to see which one is really best for this, because all carbons kind of act a little bit differently, and each water is different. And so with that, we were able to see, which are the carbons that work best, and then we were able to quickly design the new treatment facility, helped with construction phase services and startup and commissioning. And so this went online in 2020. It treated over 400 million gallons have gone through the plant so far, and everything is coming out non-detect. This was the first full-scale potable drinking water treatment plant in Wisconsin, or in Massachusetts. And so we spent a lot of time working with regulators and trying to kind of figure out what they were learning what PFAS was, and trying to figure out how they were going to regulate this, and what type of analyses need to be done, and what type of monitoring needs to be done. Next project in not too far away in Air, Massachusetts. They identified PFAS also in 2016, the Grove Pond facility. In that case, they had PFAS over 100 parts per trillion, multiple contaminants. And so once again, we took samples, carboys of water, shipped them to our laboratory, who was then able to go through these treatability studies. And in this case, we compared also ion exchange. And so we were able to compare different ion exchange resins, compare different carbon resins, and with these small scale tests, you can get your results back very quickly. And so they looked at also, what happens if you put GAC and anion exchange in series. And so trying to figure out what was the best treatment for this facility, they found that ion exchange works best for this water. And so CDM Smith designed the 2 MGD water plant, went online also in 2020, worked closely with the state throughout the process. And so this is the first ion exchange PFAS treatment system in Massachusetts. And then nearby, Spectacle Pond, as the regulations kept going down, initially their levels were under the 70-part regulation that Massachusetts first put forward, but then Massachusetts lowered that to 20 parts, and so suddenly this facility is out of compliance. So we've been working with them. Again, it's on the same aquifer, but we shipped the water out for treatment studies, and in this case we found GAC actually worked better for this water. So you really need to look at each water, and so this project was designed, and I think it's a couple of months away from construction. And then finally, just touch on the bench scale testing. Matt mentioned our laboratory, and Zoom's on the call, who kind of heads up our treatability studies. This lab has done, over 35 treatment studies focused on drinking water, where we've been able to ship the water out there. And what we're able to do is, the top photo is you see all these small columns there on the wall. And these columns are, small, rapid scale, where they've got media inside them. And traditionally, this has been very useful for granular activated carbon. And over a couple of weeks, or several weeks period, you can get results that would take months or over a year on a pilot scale. And so in this case, we can evaluate these, but we've actually shown and come up with methods where we can do the same thing with ion exchange. So we can be looking at different ion exchange resins, different carbons, and looking at how they react in series or together. some of the things, the fact that it's in a laboratory setting means that we can control for cross-contamination, making sure that your results are reliable. With this, we need to be looking at not just your target contaminants, and there's, you can see there's 2 resins on the graph there. On the bottom are all the different PFAS species. And 2 of those, PFOA and Pfas, are the ones that are showing 0 concentration. And so the 2 different resins both met the regulatory requirements, and both would treat the water. But if we look at the non-regulated contaminants, the resin 2 was doing much better. So those contaminants could be regulated in the future. And so when we got the results, the utility director said, well, that's the right one for our consumers. It's going to give them the best water quality. And so these are the type of things you need to make sure that the study is looking at is not just what's regulated, but what else is in the water. And then also thinking, well, what are the unintended consequences that can come? Because you're trying to solve a PFAS problem, and you don't want to create another problem. And one thing ion exchange resins can do, certain resins will pull sulfate out of the water. And as Matt said, we're working with you on the lead and copper, and that's something to pay attention here as you're selecting your resin. If you pull sulfate out of the water, you're changing your sulfate to chloride chemistry, which can impact your lead and copper compliance. So you don't want to solve a PFAS problem and cause a lead problem. And then when it comes to GAC, some GAC carbons have levels of arsenic in them, that they can release arsenic as the water flows through. So as you're selecting your carbons, you need to be testing for that, making sure that, again, you don't want to be putting something in the water thinking you're solving a problem and causing a different problem. But we've looked at waters from all over the country, different quality. Your water is really challenging. You've got really high organic water that's going to impact your ability to remove PFAS. Zoom is actually working on a couple of projects where other utilities that have similar water quality, very high organics. Zoom, I don't know if you want to talk about some of that.
Sure, Mark, and I think you're spot on. We're testing 40 plus, water from all across the country, some groundwater, some surface water, and we notice a lot of trend. Things like bulk contaminants, like chloride solvents, even at trace level, can impact Gac, performance and longevity. And you mentioned the high organic content present at the site here, and we notice that high organic contents, even just in 1 to 3 milligrams per liter, can adversely impact both the resin and Gac performance and really longevity. So like Mark said, doing some bench testing is what we always call, penny on the dollar type testing that can get you really good data, reliable data within a very reasonable time frame.
Yeah, and this testing really can take weeks instead of months to get good results.
Thanks, Mark. Thanks, Zoom. Just wanted to leave you in conclusion here that CDM Smith has pulled together the right team for this review project that you have put forward. One team member that I failed to mention is our risk communications professional, Mel Harklerode. And she is working on communicating risks on PFAS and lead services all across the country. I know that your communication with your public has been very transparent and out in front. It's very important to you, and that's very clear from everything that I've seen over the last 4 months. And as you kind of move forward through that, we can help provide some more content for that as well. As you heard from Mark, we have the right qualifications. We've been working on this since 2007 and continue to grow our experience and our resume in this field. And finally, we have the right experience relevant to Wausau, and again, that's really focused on water chemistry and the CCT study. Thank you.
Thank you, and you managed that time very well. Thank you for that. I think we're going to ask a couple of questions, but maybe not get too crazy. I'm going to start because I can. One of the things that I'm curious about, I've been talking to researchers at UW-Milwaukee, and I'm wondering, have you partnered with research institutions in the past on projects? One of the things they needed is an environmental engineer to kind of help be that kind of bridge between us and them. So I'm just kind of curious about your experience there and how you'd feel about things like that.
Yeah, as a matter of fact, we do have UW Milwaukee as part of our project team. I've formed a good working relationship with Dr. Marcia Silva going, I don't know, it's probably been 6 or 7 years now. We've partnered on a number of projects together. And I'm a two-time graduate of UW Milwaukee, and so I have a very close relationship with the school. We do often partner with universities on our projects.
Yeah, so I was trying to pull up the org chart, but
I know I was flipping through the thing here, but
Yeah.
yeah, awesome.
We often have universities as our project partners, and it's typically in an advisory capacity, and that's what UW Milwaukee would be here as well.
Okay, I know we have Mr. Jean, and I'm guessing we got some other questions too.
I do have one question, but I wanted to thank you Mark, for saying what you did, because we've tried to stress that an overnight fix might cause more problems than we're fixing. So I appreciate that comment. How many plants do you guys have under design right now? And I don't want to take up a lot of time.
For PFAS treatment? Yes. Like I said, there's, well, Al, maybe you've got a better handle on that. Al, are you there?
I see.
Oh.
Oh,
I
see him.
Yeah, I don't know if you're on mute, Al.
The audio cut out, I think, but
Okay.
I hear you now.
How many plants do we have under design or construction right now with for PFAS treatment? Roughly?
We think our internet just went down. but-
Okay. I know of, we've got the two there that are started up. Actually, the third one's under construction. We've got the largest PFAS project, actually using membranes down in Brunswick County, North Carolina, that's in construction right now. I know I've heard of at least 4 or 5 other ones that are in the Northeast that we're working on right now. Middlesex Water, I think, Bedford, New Hampshire. And then we've got 2 projects in Orange Grove, California, where we're doing design build, PFAS. And I know there's more that I don't know of, but those are ones I can at least talk to.
Thank you. I'm sure Mr. Robinson had a question, but it looks like our WebEx is this way. Anyone here with a question?
But a couple of questions.
I can hear you.
One deals with sequencing. One of the concerns that I have is on the life cycle cost, and do you have the ability to look at the options and try to look at our long-term cost, including, disposal is not destruction and there's liability that.
We're going to call IT. Do you feel like you have enough information to?
I can try, but I want to make sure I'm answering him.
Sure.
So I don't want to leave him without hearing the answer. But certainly I think he was asking about the life cycle costing, and so that's one thing the bench scale test does allow us to do, is to figure out what is the bed life that we could anticipate. Certainly pilot scale that you're doing in the end is even more accurate with actually predicting, but it takes so long. And so, a lot of ways you can kind of pair the bench scale testing with the pilot scale. So first figure out which are the best resins, what's the best carbon, what's the best configurations, and then take that data. You can project life cycle, but then if you want to follow that up with pilot testing, then sometimes that makes sense. But then when it comes to life cycle costs, certainly you've got to deal with carbon. The carbon manufacturers are used to regenerating their carbon, so they've already got that built in, that they're going to take away the carbon and regenerate it and incinerate it. And as he said, that's the research really isn't sure what happens to that when it gets incinerated. Does it go up in the environment, or is it destroyed? The ion exchange, a lot of the vendors don't want that back because they can't reuse it and can't resell it. And so we're working with utilities that are, identifying landfills that for now that are going to be storing that. because that's really the only choice when it comes to the ion exchange resin. We are working with quite a few places where you're looking at destruct technologies. And so we've got some of our research, and again, it was formed in the time when we were treating Superfund sites and landfill sites with a lot of contamination is some foam fractionation technologies and things, so where you can concentrate that PFAS and then get into destruct technologies. Currently, it's so expensive to destruct, but unless you first concentrate it. So, but we've got some full-scale foam fractionation places helping with Superfund cleanup, and they're working with a lot of research on that as well.
Okay, thank you. Anyone else with a question? Apologies for anyone online. We're working on getting you back. Oh, all right. Yeah, hit join meeting. Okay. Hit.
We heard that.
Yay! Okay, cool. Any other questions?
I didn't hear the answer to the life cycle cost.
Yeah, we'll go through it again.
Okay, yep.
Thank you.
Yeah, when it comes to life cycle costs, certainly we can do that with our, when we do the bench scale testing, it helps us to project what the life is for that bed, and so how quickly you would need to be replacing the media. But then, I think as you were pointing out, that it's the disposal costs need to get brought into that consideration as well. And when it comes to GAC, you've got options of getting that material regenerated back by the supplier. But when it comes to ion exchange, there is some work going on regenerating ion exchange for PFAS, but it's not something you want to do in your facility. It takes a really high pH, it takes a very high temperature and some solvents, and so it's something that generally you're not doing in your plant. The same way that you would regenerate a TOC, your other ion exchange system that's being developed. So certainly.
Sure, I would have a question for you and for all of them, and it deals with the issue of sequencing. Given the fact that we're going with a new water treatment facility that will be online later this year, and as we introduce the groundwater to that site, and the potential is for contamination of the site, or the attachment of the PFAS to the media that is passing through, and then subsequent release, where we know that there are sites where they've removed PFAS from the flow stream, but it continues, it is attached to piping and then is released at a later date. How important is it for us to have that new treatment system in place on day one when we open up that facility to avoid future release of attached PFAS?
I think my guess is, without analyzing your water yet, my guess is your ion exchange system that you're installing now is going to remove a fair amount of PFAS. It's removing organic material. It's most likely going to be removing PFAS for a period of time, but then it's not going to be regeneratable. It may not remove all the small compounds. It may be removing mostly the large compounds. And so until we get the testing to really know. And so chances are with your new plant, when it first goes online, there won't be much PFAS in the effluent, or it'll be at a lower level for these target compounds. I think that's going to give you some time to implement your full-scale system, but I think the testing and this quick testing is going to give us more answers. Otherwise, it's going to take a while with the pilot scale testing just to get breakthrough. Is going to could take months, and so it just may take months before we have the answers. Whereas the bench scale testing can hopefully get to some of those answers much quickly.
Any other questions? Thank you very much.
Thank you.
Thank you.
All right. All right, next up we have Wood.
All right. Good evening. Thanks for having us. It's a pleasure to be here. Happy to present Wood's qualifications for Pfas. Before I go through our slide deck, a short slide deck covering our qualifications, I'd like to introduce myself. I'm Evan Thomas. Give you a little background on myself. I was actually born and raised here in Wausau, and I started my engineering career by working for the city of Wausau. I was a surveyor for a few summers working in the engineering department. I still have family here in town, so I come back frequently, and I do have a vested interest in the city and the success of this project. Currently, I live in Madison, where I lead Wood's operations for the state of Wisconsin. I've worked on PFAS projects here in Wisconsin since 2019. I've been managing projects for the Wisconsin DNR in both Marinette and the city of, or the township of Campbell on French Island. Wood as a company has been supporting the DNR as a PFAS consultant, as a PFAS technical expert and an advisor for those high-profile projects, but also just generally as part of their Office of Emerging Contaminants. Wood as a whole has been involved in PFAS projects for almost 2 decades, dating back to the early 2000s, and many of our PFAS experts are located here in the upper Midwest. We do have experts from around North America, and we pull experts in to serve different challenges and really kind of build the best team for each of the individualized projects. So, well, I have the same problem. There we go. Okay, so with me today is some of our team members. So we've got Hannah Albertus Benham, engineer, assistant project manager. Hannah's coming from Minneapolis, and Hannah's going to talk a little bit about our East Metro project and Wood's involvement there. I also have Dave Woodward, Wood's PFAS technical director, coming from Harrisburg, Pennsylvania. Dave is filling in for some of our PFAS experts who are committed to a PFAS conference in Boston, actually, today. We do have PFAS experts that really kind of fit many different molds, including experts who focus on fate and transport, risk communication, risk evaluations, and water treatment, of course. Okay, so as I mentioned, Wood has a long history within PFAS, and as part of that 20 years or nearly 20 years of experience, Wood has developed a number of different PFAS treatment systems. These treatment systems have included a number of different treatment technologies, including GAC, granulated activated carbon, ion exchange systems, both single-use and regenerable. We were familiar with systems that needed to treat co-contaminants or the need for pre-treatment ahead of any PFAS removal. Our staff have worked very closely on a number of projects, from conceptual studies, desktop evaluations, evaluating various feasibility studies, to bench or pilot tests, and then of course full-scale treatment systems. One great example of a treatment system we've developed is the Pfas Air Force Base, which is located in New Hampshire. It's a groundwater contaminated site, CERCLA, Superfund cleanup site. And our groundwater treatment team developed the first ever regenerable ion exchange treatment system there. It was developed in close collaboration with both EPA Region 1 and the New Hampshire Department of Environmental Services. That project was so successful that the EPA awarded our team the 2019 Outstanding Achievement Award. To date, that project has removed more than 41 million gallons, or treated more than 41 million gallons of water, removed PFOA and PFOS to non-detectable levels. The regenerable ion exchange is obviously reducing the offsite waste management costs. So our team is comfortable in both proven and developing innovative novel technologies to tackle these treatment system needs. As part of developing these specialized treatment systems, we look at treatability studies to help optimize these systems. And so Wood has 3 full-scale treatability labs in San Diego, Atlanta, and Cambridge, Ontario. These labs help optimize treatment systems, not just at the front end when the system is being designed, but really throughout the project lifecycle. So as treatment systems, the technologies develop, the treatability systems and treatability labs can help evaluate new technologies. As you can see, we're familiar with a number of treatment technologies, including GAC and ion exchange. One example project where we've used a treatability lab and treatability studies is a landfill project in central Michigan. PFAS contaminated groundwater there. Our project team developed full-scale treatment system there from the consulting and engineering side. We developed both bench and on-site column tests, treating the on-site water to expedite the design of that system. We then supported procurement and construction of the treatment system. It consists of 3 ion exchange vessels to treat the PFAS, and there was also VOCs on site, and an air stripper was used to treat those. So as I mentioned, team used treatability studies to optimize that system. I'll also mention that Wood is involved in research and development within the PFAS world, and so we have more than $3 million on contract right now to develop treatment and destruction technologies. Our team is very familiar with R&D, and we have a number of peer-reviewed articles that support the development of these treatment and destruction technologies. So as a leader in PFAS, Wood is always trying to look forward, trying to help anticipate what might come down the pike. And as part of that, we expect that PFAS destruction will become an important component. So if we take just a step back and think about what is treatment, it really is an idea of separating and concentrating PFAS out of source water and then destroying or disposing of that material. And we know that the US EPA's recent roadmap for PFAS is stating that they'll plan to classify PFAS as a hazardous substance later this year. And when that happens, costs for disposal are likely going to go up, and the logistics of actually handling that waste will also become a potential challenge. So our team recognizes that, and we know that treatment systems as a whole are never static and will need to be able to adapt and evolve to both the changing regulatory environment, but also to the changing technologies as they advance and improve. All right, so with that, I'm going to hand it over to Hannah, who's going to introduce the East Metro project. East Metro project is a project in Minnesota where we've provided strategic consulting to the state of Minnesota on their PFAS issues.
Great. Thanks, Evan. That was a great summary of Wood's PFAS expertise. I just want to, kind of recognize the team here. Evan brings the Wisconsin to our team, and we've got Dave here representing our kind of global consulting and world of expertise. And so I'm here to talk about one project I think that really is a great example of how we've used that expertise for a project like this, and specifically in kind of providing that technical advisor role. So the state of Minnesota, for those who aren't familiar with the project or the situation over there, the state sued 3M company, for contamination that was impacting 14 communities, or is currently impacting 14 communities. And they're kind of shown on that map there on the cover page of the Conceptual Drinking Water Supply Plan. And we were brought in after the settlement was reached in 2018 for $850 million. The state went ahead after that settlement and put together work groups. Those work groups met on a monthly basis. And do I need to pause? There are technical difficulties again?
Can you hear us? Okay, good. We don't know what's happening here,
Okay.
but.
Okay. So the state brought us in after those work groups had started meeting on a monthly basis because they kind of recognized that there was that need for a PFAS expert, and we had already had experience with the state, and they brought us in that capacity. So we immediately began meeting with the communities and starting to develop the plan. So what we brought to those communities, those 14 communities, about 170,000 residents in total, a large area, 150 square miles. And so our job as the not only PFAS experts, but also looking at a conceptual water supply system. So taking into consideration all of the different communities and what their water supplies currently look like, what they might look like in the future.
Studying among yourselves. It's interesting.
Oh,
There we go.
Can you hear us again?
Yes.
I don't know what's happening. It keeps telling us we're connecting. Nope.
do you want me to keep going?
Yeah,
Okay.
you might have to fill folks in.
Sure. No problem. Okay. So I guess coming back in, so we helped the state as well as the communities. The work groups consisted of, community members, community leaders, and as well as 3M themselves. And then also working with all of the different agencies involved. We built a groundwater model to model the groundwater movement in the area to try to see where it might move in the future. We put together a drinking water model, so we modeled all of the different drinking water systems individually and then looked at what they might look like together in different groups. And we really tried to see, what the best solution is, how the best use of those funds are for the future. So we developed that process of evaluating options. So it's not just about looking at the options, but you have to have a way of ranking them, comparing them to each other, which can be a difficult challenge through that process. Obviously put together a lot of costs. So we're very familiar with conceptual level down to obviously, the detailed level of costs. And we worked one-on-one with the communities. That was a really, really huge part of our process. Was meeting with the communities one-on-one, specifically their technical staff, to really get a good feel for what their challenges were, even on a conceptual level. So we did that technical legwork, and part of that also included reviewing technical components of that, such as, some of the communities are doing pilot studies as well. So we did review of those pilot studies and provided technical feedback to help kind of make those the best that they could be. We continue to engage with the communities through after the plan. So the plan was released in last year, 2021. And since then, we've been working with the state to kind of review all the plans coming in and make sure that the funds are being used according to the plan that we put together. So I just wanted to emphasize that throughout that process, we've been working as a team within Wood, and I've been working personally with all of these experts throughout this process. And I think one of the things is just having those experts accessible and ready to answer any questions that might come up throughout that process. So hopefully that gives you a little bit of insight in how we can help the city of Wausau and provide that technical advisory and specific PFAS experience for you all. And I'll turn it back to Evan.
All right, well, thanks, Hannah. So that concludes our presentation. We do have some information after this with recent publications, some of our recent examples of work, but otherwise we're happy to take any questions that you might have on those or really anything related to our PFAS qualifications.
Okay, thank you. Does anybody here in the chamber have some questions? Yes, Mr. Jean.
Just one question. Is there a Mr. Wood, or how'd you come up with the name?
I'll let you take that.
The John Wood Group was formed in Scotland and was originally a shipbuilding company that when the North Sea opened up for oil exploration became an oil and gas company and then an engineering company, and have evolved into a multidisciplinary 40,000 person international engineering company now. So it's the name of our founder.
So, yeah, Mr. Forrest.
Aren't you building a plant at Woodbury? I don't think you pointed that out.
Yeah, so the communities themselves all have their own consultants. So we're very familiar with working with other consultants in that capacity. We are working for the state. So the state administers the funds from the settlement as co-trustees of the settlement funds. And so we are in that technical advisory role, reviewing when they submit a request for funds. So they submitted a request to do like a pilot study, and they submitted a request for funds to actually put together the engineering drawings and everything, because that takes millions of dollars as well, as you might know. So we reviewed kind of those plans and made sure that the costs are in line with the plan and there's nothing exorbitant there, and it all fits
But
within
someone
the
else is
settlement.
designing it.
Correct.
Thank
Yep. In this case, other folks are designing it and we're just in a review capacity.
One other question. The Tulchin A72, you had it on your slide. Is that the regenerable resin that you referenced? Or is that something else?
So that's the resin that's planned to be put into the new treatment plant to treat for TOC and color. And so that is an example of a resin that can be used within our treatability lab or on-site column tests to treat its effectiveness at removing PFAS in addition to the TOC and color.
And what is your firm's relationship to that product?
To my knowledge, we have not
No.
used it.
Yeah, that's the resin that you guys are testing, and we were just trying to say, we're familiar with it.
Familiar with that
We've used
brand.
it ourselves.
Thank you.
Any questions? I know that Mr. Robinson had a question. He said he was going to ask everybody. Trying to recall what that was. I think it had to do
I can
with,
address that.
Yeah.
I think it was the sequencing.
yes,
question.
sequencing. That's right.
Yeah, and
Thank
if
you.
you don't mind, I'm going to make another supplemental comment. You know, one of the things I've learned working with PFAS for 20 years is we talk about a treatment project, right? This isn't just a treatment project, I don't think. This is a contamination problem, right? So the solution has to be, yes, the first step is you have to deliver clean water to the people, but maybe you can do something about the source and find it and cut it off and maybe extend the life of your treatment, better understand the fate and transport. Maybe if it's the nearby Superfund site, they can put a pump and treat system in to prevent the PFAS from being drawn towards your supply well. So a lot of times it's really putting together the whole picture, right? The conceptual site model, where it's coming from, you know, the treatment, you can do that, and that's step one. But do you want to treat and dispose of this waste forever? Because PFAS hangs around for a long time, right? So the sequencing I wanted to address is the odd thing about PFAS, right, is to really remove PFAS well, you got to remove everything first. So I hope I don't get us in trouble by saying, in this situation, PFAS treatment isn't the hard thing, right? It's the pre-treatment and getting rid of the other stuff so that you can successfully, you know, I'm not downplaying the, you know, the significance of column studies and picking resins in GAC, but I would bet a lot of money that you're going to end up with one of those because the other technologies just aren't necessarily ready, right? But you're removing iron. You're going to have PFAS in your iron sludge. That's going to be a disposal issue, and very soon, it's going to be hazardous, and we're already seeing that the waste management companies are treating it hazardous anyway. So I won't name the name of the company, but one of them has already decided the only place we're going to accept PFAS is on the West Coast at a tremendous transportation cost. So now it's hazardous, it's more expensive to dispose of, and you got to ship it a long way. So in terms of sequencing and life cycle, you want to get to the point where you can either destroy it yourself on site, and that's what a lot of the R&D focus is that we're working on, and that's very viable in the future. I would say 3 to 5 years, I believe people will be destroying PFAS on site. So, you know, your life cycle might be treatment, get rid of the source or help cut it off or make sure somebody else does, and then destroy it, right? And then if you do have to treat it for a long time, the destroying it on site is going to ultimately be way cheaper, and you won't have the liability associated with a landfill. So.
One of the things I wrote down from one of your pieces was a microcosm study. Can you just tell me a little bit about that?
It's just a different form of bench testing.
Oh, okay. I've been hearing about mushrooms and hemp and all various kind. I'm just curious where that's at, but
Everybody's trying to treat PFAS with everything, orange peels and all kinds of things. So you'll hear lots of wacky things.
cool. Any other questions? Okay, thank you.
Thank you.
The life,
Thank you.
Oh,
the life cycle cost?
Life cycle costs.
You're back.
I'm
Thank
sorry.
you.
I think he wasn't on when I talked to her.
No.
Yeah, I just addressed sequencing and, you know, the bottom line is, you're looking at a treatment project, but waste disposal is going to be very expensive in the future. So looking at this in terms of the treatment life cycle itself, but even the bigger picture of, hey, maybe we can get to the place if we find the source and we put pressure on the source, maybe we can get to a point in the future where we no longer need to treat it, or the treatment materials will last longer because concentrations are going down, right? So we certainly address life cycle costs. The way I answered the question, and I think you're recording this, you could maybe go back and review it in a little more detail. But, you have really three segments, I think. Get the treatment in place, right? And then hopefully do something to eliminate as much coming towards your well fields, or people are putting new well fields in new places that aren't contaminated. There's other options there. And then once you've sort of settled down and you've gotten rid of what you can get, you've got a good treatment system, then it's about optimizing that treatment and taking advantage of the on-site destruction technologies that I believe will be available commercially in the next 3 to 5 years. So you concentrate it, destroy it on site, you don't have the long-term liability, so your life cycle costs will go down as well. And there are mobile gasification systems, for example, that are being used right now to destroy certain Pfas. And we've got a new R&D grant from the U.S. government to explore gasification as a technology, and you could feed it any solid waste, right? You could feed it resins, carbon, protective equipment or clothing, filters, any kind of solid waste, and it would destroy it on site. And the technology is demonstrated. It's just not demonstrated for all of those different matrices, different sources of material. So I hope I answered your question.
Any other questions? Okay, thank you very much.
Thank you.
Thank you.
Oh, yeah. Oh, yeah, we can. That's mine too. So just mine too. Oh, I don't know. All right, next up we have Shannon and Wilson.
Guess not.
Guessing maybe they.
Good evening. My name is Mark Burkowski. I'm the principal in charge of this RFQ response, as well as the Shannon and Wilson Madison office manager. Good evening. My name is Mark Burkowski. I'm the principal in charge of this RFQ response, as well as the Shannon and Wilson Madison office manager. I'll be joined later by Kristen Freiburger, senior chemist and chief subject matter expert at Shannon. Do I just go over the slides? It's everybody's not allowed.
All right, we're just gonna give ourselves a little bit of time to figure this out. If you gotta stretch your leg or something.
It's a voiceover slideshow. That doesn't help when we're already having issues.
Good evening. My name is Mark Burkowski. I'm the principal in charge of this RFQ response, as well as the...
Is that better? Can you guys hear it? Yes, go on.
Our presentation will focus on the following items, including a brief background on Shannon & Wilson as a firm, a discussion on our approach to the project based on our understanding of current needs, PFAS project examples, review of project funding mechanisms, introducing our teaming partner, and summarizing the strategy and other considerations for this project. Our company was founded by Bill Shannon and Stanley Wilson in 1954. From the very beginning, they addressed large-scale, high-profile, technically challenging projects, a practice that Shannon and Wilson continues today. With regional offices across the country, we provide local experience backed by national resources and expertise. Our diverse staff of over 300 engineers, geologists, hydrogeologists, and technical staff allows us to provide flexible, rapid responses to our clients' needs. Shannon Wilson also provides a wide variety of environmental consulting and engineering services for our clients. Company-wide, we have completed a number of PFAS and water system projects. Since 2017, our expertise includes 27 PFAS projects, 8 with community wells, and 52 municipal water supply system projects. We are endorsed by the City of Rhinelander in addressing their public water system issues as well. Shannon and Wilson are also active members at Wisconsin Rural Water Association. We have submitted a paper on PFAS community project management and planning for a presentation at the American Water Works Association Wisconsin Chapter's annual conference this September. Our project approach is focused on the most critical parameter, the protection of human health. Protection of human health is a basic fundamental concern that requires immediate attention and corrective action. We understand the importance of the City of Wausau and the Wausau Water Works' ability to provide safe drinking water to its residents. And Shannon and Wilson recognizes the need for reducing and removing PFAS from city water supply as an appropriate immediate response to the concentrations of PFAS that were detected in all 6 municipal water wells above DNR health advisory limits. As proposed, the drinking water treatments include a variety of existing and developing technologies that include granulated activated carbon, or GAC, ion exchange, Thermax resin, Sorbix resin, reverse osmosis, and other proprietary filter or treatment media. That said, PFAS are hard to treat. PFAS are everywhere, with potential sources existing in groundwater, surface water, soil, and even in the air. So as proposed, our project approach wants a review of all treatment media and even more options that are available through a number of contractors that specialize in drinking water treatment systems. Because the new drinking water treatment facility is so far along in its construction stage, with an August 2022 proposed startup, it may be more cost effective to have existing engineering firms of Donahue and Becker Hoppe contract directly with a drinking water treatment firm to complete the bench scale testing and add treatment trains to achieve the initial goals of PFAS reduction at the drinking water treatment facility. As part of our project management, Shannon Wilson can facilitate the water treatment contractor selection process. Shannon Wilson's approach to the City of Wausau's PFAS drinking water issue is a long-term solution to Wausau's water problems, involving defining the nature and extent of PFAS impacts in soil and groundwater, as well as devising a well-field protection strategy. It is not economically feasible to treat Wausau drinking water for PFAS into perpetuity. This map shows the locations of the 6 wells impacted by PFAS. We've also provided a summary table identifying the well locations, the pump capacity, volume extracted in 2021, dates installed, total depth, the geology where the water is coming from, the source water itself, and the results of the PFAS sampling completed in 2019 and 2022. As a Wisconsin company, Shannon Wilson has partnered and has funded PFAS research with the University of Wisconsin-Madison's Environmental Engineering Department to investigate the closure of 2 of the 5 City of Rhinelander municipal wells due to EPA health advisory drinking water exceedances. These wells were located near possible sources of PFAS contamination, including firefighting foam, municipal sludge management areas, and solid waste landfills. Coincidentally, with the exception of the suspected source areas, the cross-sectional model provided here is similar to the well field configuration for the city of Wausau. Highly permeable sand and gravel aquifer, shallow high-capacity wells, crystalline bedrock, and a hydraulic connection to the Wisconsin River. Our field research that was completed for the city of Rhinelander includes sampling PFAS in soil and groundwater, geophysical investigations used to evaluate the aquifer characteristics, and PFAS fingerprinting to analyze and link PFAS sources to PFAS in groundwater. At this time, I'd like to introduce Kristen Freiburger, again, senior chemist and PFAS subject expert, to talk about some of her project work.
As Mark mentioned, my name is Kristen Freiburger. I am the environmental group lead in our Fairbanks, Alaska office, and I have personally been working on PFAS projects for over 8 years. Shannon Wilson has been working on PFAS projects with several different clients throughout the years, but our largest set of projects is on a 15-year contract that we won with the Department of Transportation here in Alaska. As part of that contract, we are investigating 30 different airports where AFFF has been used. And I'm going to highlight a couple of those projects in these next slides. Next slide, please. Thank you. One site that is part of our work with DOT is the Fairbanks International Airport. Our client detected PFAS in several wells on site during an investigation, and since the groundwater in this area is known to flow towards private wells, DOT contacted Shannon and Wilson, and we quickly mobilized to collect samples from the private wells near this airport. This map shows the results of those samples. Red indicates locations where PFAS concentrations exceed the EPA LHA, or 70 parts per trillion for PFAS and PFOA combined. And these homes have since been hooked up to a municipal water system as a long-term water solution for their home needs. Next slide. At the Fairbanks International Airport, we also completed a pilot study to investigate the effectiveness of Plume stop for sequestering PFAS. Plume stop is a colloidal activated carbon that's injected into the ground. We did this in an area that was known to have high levels of PFAS contamination, and the material was formulated to sequester 5 PFAS compounds: PFAS, PFOA, PFHPA, PFHXS, and PFNA. This work was completed in partnership with our client, DOT, and also the manufacturer, Regenesis. Ongoing monitoring has occurred for almost 2 years, and during our last sampling event at the end of that 2-year period, the 5 PFAS compounds the material was designed for were not detected. We're currently investigating how this technology can be used at several of our sites that are part of our DOT contract. Next slide. Another airport that is part of our DOT contract is the Gustavus Airport, which is located in southeast Alaska. Our project kicked off with a well-attended public meeting, shown here, in 2018. At that meeting, we informed the public about the contamination in the area and scheduled appointments. This project has also included installation of a point of entry treatment system at the Gustavus Inn. That system uses Gac. And after 2 years of monitoring, PFAS are still not detected in that system. It also includes the removal of arsenic, which remains non-detected to date as well. We are currently investigating additional remedial options for soil and groundwater contamination in this area and connecting homes to rain catchment cisterns, and also installing a public well for supplemental purposes for those cisterns during dry periods.
Thanks, Kristen. Thanks for the updates on your projects. Well, as we move forward, Shannon and Wilson have identified a number of project funding mechanisms that are available for the investigation and remediation of PFAS in soil and groundwater, as well as a number of grant and loans
available for infrastructure improvements for water systems that are impacted by PFAS. As of March 18th at the Wisconsin Rural Water Association Conference, the DNR is still waiting for the EPA to determine the vehicle for providing the funds for these projects. Orrin Technologies is our teaming partner, and they have experience with using a variety of chemical reagents, biological, organic, and inorganic, to break down PFAS in soil, groundwater, sludge, and even in FFF. That's the firefighting foam that is the major source of PFAS impacts to soil and groundwater. Orrin is currently working with the DNR on a number of pilot studies and at a major airport in south central Wisconsin. Orrin would be providing these same technologies to the city of Wausau's PFAS projects. As an approach to addressing the immediate health and safety concerns for the city of Wausau, Shannon Wilson recommends that the city of Wausau, the water department, Becker Hoppy, and Donahue, with the assistance of Shannon and Wilson, identify a specialized water treatment contractor to provide the appropriate media and treatment trains to achieve the goals of providing safe drinking water to their constituents. Services completed by the selected drinking water specialists would include an evaluation of the available treatment technologies and contingency planning based on future potential EPA health advisory standards. Concurrent with the upgrades to the drinking water treatment facility for PFAS, drinking water reduction and removal, Shannon and Wilson proposes to evaluate and inspect the existing wells, complete a well field assessment including groundwater capture modeling to determine source areas impacting the existing well field, access considerations for well field development, including well relocation, exploring non-PFAS impacted areas for sources of community water, and provide remedial solutions that have been successful at other locations in reducing PFAS in soil and groundwater before the groundwater gets to the drinking water treatment facility. And while the city of Wausau and the water treatment facility have a desire to immediately address the public water system, the existence of private wells that are used by the community outside of the service area may be another consideration. It would be important for the city to provide clean water for the majority of Wausau residents outside of the current service area. That would add additional ratepayers into the system. Expanding and seeking other sources of community water outside of the current well field may also provide the capacity needed for this expansion. And well field expansion may also be used to blend down PFAS impacted water at concentrations below regulatory health advisory standards. Funding is also anticipated for these system upgrades and assessments. So we appreciate the time and your consideration and look forward to your decision on moving forward with this project. Thank you.
Okay,
So I'm unmuted for some question and answers if you have questions for me.
They're completely virtual, right? But they're not. All right, thank you. I guess we are moving on to.
The life cycle cost?
So I think we're gonna have to send them the questions via email since this was a virtual present or a pre-recorded presentation. Yeah. Thank you. You are all of us.
Can you hear me? I can.
Oh, we can hear you. Ah, okay. Robinson's life cycle question. You're on deck.
Life cycle question for the treatment systems. That's for the service providers that provide the treatment trains and some of the other consultants that will be presenting their technologies today. Our proposal is really about wellhead protection and making sure that the water that you're bringing into the system isn't impacted to begin with. So we decided to take a bit of a different approach, which was actually part of the RFP response.
Does anyone here have follow-up questions? Seeing heads shaking. No, thank you very much. I think we're.
Thank you.
Thanks. All right, we are moving on to Tetra Tech.
Hello, all. Good evening, Commission members. My name is Marcia Moret, and I'm a senior environmental scientist with Tetra Tech's local Schofield, Wisconsin office, and would serve as the project manager for this project if we were selected. I'm joined tonight by my Wisconsin colleague, Jamie Dixon, a senior professional engineer and the office manager of our Brookfield, Wisconsin location. We really appreciate the opportunity to share Tetra Tech's PFAS experience with you and hope you'll find it valuable as well. I'd also like to thank you on a personal level. As a lifelong resident of Wausau, my husband and I were both born and raised here. Our son is a sophomore at Wausau West, so this community is near and dear to me, and the reason I returned here after college, and I've spent my entire career here with the local Tetra Tech office. And its predecessor companies, which have been conducting environmental projects for over 35 years, including for the city, starting out as Twin City Testing, then being acquired by Huntington Engineering and Environmental, followed by Maxim Technologies, and then Tetra Tech. So it goes in consulting sometimes. And we'd be very honored to assist the city and its team with this important project and to implement the best drinking water treatment solution for all the residents of Wausau, including our family and friends. So I'm going to give you a quick overview of Tetra Tech. We are a global company with 21,000 plus staff in 450 offices worldwide. Our motto is leading with science to seek clear solutions for our clients. And due to that extensive global reach, we have a lot of PFAS experience, including water supply, wastewater treatment system designs, treatment technologies, pilot studies, as well as investigation and remediation, and also skilled in communications, outreach, and training, and project and budget management. Our one noteworthy recognition is that Tetra Tech has been rated #1 in water projects for 18 consecutive years by the Engineering News Record, which is a ranking given by peer groups. And that's due in part to the long history of our drinking water treatment facility design expertise, which includes the traditional considerations of disinfection methods as well as corrosion control and other treatment methods. And that goes for wastewater as well. We have an extensive history of wastewater treatment design. And one noteworthy point in that regard is that for over 10 years, we've offered wastewater operator training courses for which attendees can earn continuing education units and professional credits. I'm going to quickly go through some slides that's showing our projects across the globe and through the U.S. The first slide shows projects across the globe, including Australia, which is the place where a lot of innovation first was started with PFAS treatment. And then the U.S. map shows a lot of our projects that were completed for DoD clients, but then also commercial, municipal, and industrial clients as well. And they involve partnerships with evaluation of treatment technologies with the DoD and also universities. It's not working. And finally, our Wisconsin PFAS projects count is currently about 10, but it grows constantly. Last week, we started a new investigation in the western part of the state for an industrial client. They involve drinking water, groundwater, soil, and leachate investigations. We share knowledge with the DNR, and they've come on site to some of our projects to observe and learn from our sampling protocols. And then just in general, we've had a long history of working with the regulatory agencies throughout the course of all of our environmental projects, and several were conducted directly for the DNR. And then, just to wrap up, I want to mention our project experience with the city of Wausau. As part of our long history here, we've done several projects for various city departments. And one of our team members, Lori Huntoon, has also had a historical experience with the Superfund site and the siting of some of the municipal wells here. Lori couldn't be with us tonight. And lastly, we've also worked with Becker Hoppy over the years and with other firms as well. We're very good at collaboration with other firms. And we've got a long history with experience at the Marathon County landfill. And our Wisconsin landfill engineers have helped design cells there and provided other services for the landfill. So we have that long history of successful projects, and we hope to continue that and provide assistance on this important project. And with that, I'll turn it over to Jamie Dixon to talk more about PFAS treatment technologies. Thank you.
Thanks. Might have to erase this a little bit. All right. Good job, Marshall. All right. Yeah, I'm Jamie Dixon with Tetratec. And we know the important thing here is you guys got to protect your drinking water up front. So we looked at only NSF certified type technologies that have been approved by other places for drinking water, which include reverse osmosis, granule activated carbon, which everyone's talked about, and ion exchange. So we're really focused on those, and just we've done pilot studies and other things in the past. And I wanted just to go through this and get some ideas of what's what, so that you can see. So I've reviewed your system that I could find available online, and your new water treatment plant that you built is about 4.8 million gallons per day, or about 33 or whatever gallons per minute, which is about 3,000 gallons a minute. And the max peak stuff is about 9 million gallons per day, which is about 6,250 gallons per minute. So this range of system flow rates we need to deal with would be in that range. You got the TOC and iron manganese issues. You've got wells 3 and 6, which we've talked about earlier, that have impacts with VOCs. Even though they're below the MCLs, they're still above the cleanup criteria the last I looked anyway. So those need to be maintained and operated, and I understand they operate one at a time so that there's always a net draw from those areas. The remaining wells are about 2330 to 50, about 5,000 gallons a minute, depending on the configuration to meet those peak flows. So ideally, based on all the stuff we looked at, the thing would be to stop the PFAS from getting into new treatment plants, since it's not contaminated now, and we wouldn't want to contaminate it to start with. So what we've looked through, identified it would be great to put a pretreatment in, and where would make the most sense to do that. So looking at your publicly available documents, we find you've got 3 and 6 that are feeding to the air strippers, which are being built there right now for your pretreatment for wells 3 and 6. And that's a separate manifold of 18-inch ductile iron versus the 30-inch ductile iron coming in from the remaining wells. So since you have those wells in that place right on the front end of your plant, we might have some footprint. You might have a place where we could put a pretreatment system before we hit the actual plant and start to contaminate it. The reason I'm really concerned about that is you have a lot of things in it. The sludge is going to go someplace. You're going to have PFAS in the sludge, which was mentioned before. On top of it, your filters have anthracite, which is a carbon. It's going to load up on that, and on top of it, it'll be released once you start cleaning it. So you've got issues on the back end and the front end. I think the best solution that we see based on the pilot output is to pre-treat it. So let me just go through a couple of these technologies quickly. Reverse osmosis, high pressure through a membrane, filters out all the PFAS, it concentrates in the brine, you got to dispose of the brines there. We still have the same issue we have other places. We've done this at a lot of Air National Guard bases, smaller communities. They're pretty cost effective for small units, but probably too much for this size, even though it's been done other places, but I think it's not the option we want to look at. Then granule activated carbon was the first on the scene that was used a lot of places. It has a very large empty bed contact time to meet the same removal proficiencies that you have for resin. Therefore, you have to have very large vessels. You need a huge footprint, and it's usually about 3 times the size of an ion exchange option. So double to triple the footprint, large capital investment because the size of the vessels is so much bigger. And it requires a backwash system because they tend to plug up. So if you're backwashing it, there's another source of PFAS that's coming off the GAC that you got to deal with. Large media spent for disposal. So if you do have to haul it out west, the larger the volume you got to haul, the more it's going to cost. So that's the other side of it. Tends to be an issue. So we ruled out GAC as an option based on the pilot study results, obviously. So then we have ion exchange, which everyone has talked about. There's a couple different types and different resins. We've specifically gone through a couple evaluations, and you're running a Purex from ECT2 right now on your pilot study. That type of stuff seems like it would work based on discussions with them with the chemistry that we see now. Until you actually test it, we won't know all the details. But it should work. It usually has a 2 to 3 minute empty bed contact time, which means smaller vessels, smaller footprint, easier to treat. It's also least expensive capital investment up front and the smallest media volume generated for either energy recovery or disposal. I'll talk about energy recovery later. So this is my preferred option that I went through based on a preliminary evaluation. We have a site in Orange County, California that we put in for 5 months. We actually went from design to build and installation and operations. The system consists of ion exchange like this with vessels from Voqua, which I understand they've come here and talked with you guys. The system has those in our current design. Basically, those vessels can be used for GAC, carbon, or they can be used for resin, or they can be used for any type of resin media that we want to use. So it's a pretty flexible system. We think that the size we have there, which is for 2 wells, which is up to 3,000 gallons a minute peak, is a good size for a couple modular systems to put in the front of your site. So if we've got the ones that are going to the air stripper, that's separate. That's 1,100, 1,400 gallons a minute. We need to put one system for those because they're separate and going to a different discharge location. And then if you look at the PFAS treatment of the remaining wells, when they might have 1 or 2 of the additional train systems, which I'll show you in a minute, to do it. This is one we installed in Orange County, California. So basically, you see this, you've got resin vessels. They're in a lead lag configuration, which means you can sample between them, ensure that non-detect water gets to your system on the back end. It also has 2 in series, so basically to change one out, you can put the other in service. It also allows you to do short-term dual train parallel operations to get up to 3,000 gallons a minute to give you flexibility during operations when you have a higher peak demand. This has a filtration system. This one actually has corrosion control and chlorination. It goes right into the water main from these 2 wells. So it's separate from yours. Yours already has a system on the back end, so we just need to do the pre-treatment part. There's also booster pumps, so if necessary to get additional head loss, those could be added in where it can run by them, or it could be used if necessary based on the conditions of your plant. I also show you there's a Gac Footprint, which is about 3 vessels. They're all the same size vessels. So that plus the backwash tanks takes a lot bigger footprint than it does for the smaller ion exchange system shown on the left. This is an example of breakthrough curves and how they did some of the life cycle evaluations in California based on real operations. So if you look through, as you get breakthrough curves, you can have non-detect on the backside of the water. You want to operate where that's going to be optimal, and you minimize your changeouts because that's where the costs come from. Let's see. So as was mentioned before, the disposal options are pretty limited right now. There's a potential of incineration, which can't be done for DOD sites, but municipal sites are still accessible. If you get the temperature high enough, you destroy the PFAS, and that would be one method that could be used for energy recovery, like some incinerator that actually use it for generation or power generation or cogeneration. That might be an option. The other option is landfill in a dry climate, which is hauling out west. So if we're looking at that option, we're talking smaller volumes and smaller haul things that would be less expensive to haul and dispose of. We've also done some evaluations of liquid waste acceptance, not that it applies to this directly, but if we were looking for other things like, say, your biosolids or some other back end, we've got a couple vendors that we've contacted and actually got acceptance of a waste with PFAS in it before, so they're listed. So what can Tetratec do for you? Well, we basically have a lot of experience. We've been installing like 5 systems like this, up to 20 million gallons a minute out in California area. The criteria there for PFAS and PFOA are like 6.1 and 5.1 out in California, so well below your 20. So that's a positive. It's been operational, and everything's been working successful at non-detect levels, and we think that's a good choice for your system. And then we also have done quick regulatory approval. We have designs on the shelf with this equipment that we could streamline the design process. Discussing it with our vendors, ECT2 and the other one that we've dealt with is Voqua. Voqua might actually have these vessels handy where it could be done in a relatively short term, and you might be able to still meet your August or September startup deadline of your water treatment plant. So it's a big positive process. We've also done long-term pilot testing and assistance with community outreach. And then some other things that are about us after that. PFAS emerging contaminants, yes, we have some destructive technologies that we have licensed. We've actually worked with universities. We got 5 at least we've done for intellectual property rights. We've done a lot of work with the Department of Defense. We've also looked at biochar and other type of things similar to the ORIN process, which we met with them in our office a few weeks ago. So these are all things that can be done for destruction. We've also done other things for soil or biosolids. You've got soil washing, you've got absorbents and binder agents to be able to keep it from creaking. So this is for your other waste, not your drinking water specifically, but other things we may need to help you with. And also we have a current wastewater effluent study right now that's currently concluding in a phase 2 biosolids and sludge treatment study, which is in the near future to begin, which is all valuable data that could be down the road used for your other problems. We've been working with the DOD, and especially in Australia, which is first to the curve on dealing with the PFAS issue, some 19 years. So with our DOD relationships is how we've been working so long in this field. And we have a lot of experts that we can tap in if needed. And also we provide PFAS, fate and transport modeling and other things in training and that type of stuff. So we don't need to do any more. So basically, that's our presentation. I was trying to keep it brief. So hopefully, if you have any questions, let me know.
Sure. I know that Robinson probably wants to ask his question about your
Life cycle costs.
Yeah.
Yeah, so basically thinking the resin being the lowest potential disposal. Now, in reality, once you get this implemented and you guys are safe on your drinking water side, we want to look like other people had mentioned, ways to minimize it coming into your system to reduce those operating costs over time, like an in situ maybe remedy, which that doesn't have to be NSF certified at that point. So then when it's getting to the wells, you could pre-treat it and maybe minimize your waste disposal and your resin will last longer. So that's one of the options that we're looking at. The other thing is the resin itself being smaller in the volume, and you could send it out, if you had to send it out, or energy recovery, because it has a good fuel value of the resin, because it's like plastic. So it burns really well for like a regeneration, cogeneration facility that might take it for generating electricity. So we need to look at all those evaluations and see what the best cost option is. But based on what we said, compared to carbon, which is the volume doesn't last as long. The bed volumes only last about 50,000 bed lives versus 100,000 to 150,000 for resin. You're going to have a lot less volume, and it's going to be disposed of much less expensive because there's less volume that has to be hauled long distances. Any other questions?
I'm kind of curious, since you brought up the biosolids and the sludge. I'm curious what you're seeing as it relates to that, because I do feel like that's probably the next thing on the horizon.
Yeah, my first vote,
regulatory.
I mean, based on the review of your design, everything that you get off your regen systems is all going to your sanitary right now anyway. Now, it's not to mention something that's going there now, but you need to add another stream. If we had backwash systems, that's the issue. So then you have to deal with the biosolids, and everything I've talked to is, what are you going to do with those? We might have some other solutions that could help dry those, maybe and containerize them and move them. You don't really know, that's all in development mode at this point. The drinking water is my primary thought, so.
Any questions from the chamber here? Yes, Mr. Force.
Have you done this pre-treatment approach in other sites? Maybe you haven't, I missed it in the presentation.
Yes, in California, it's a pre-treatment, basically, solution that's untreated. I mean, actually, this one, they have a filtration bags on the front, which could be added if it was required. All that does is take some of the solids out. And the other thing is the resin is selective. Right now, we've got Pfas, which is a negatively charged, and you need a positively charged resin in order to capture it because it's the opposite charge to attack. Your TOC stuff right now is a negative anion catalyst, so basically it's not going to do a really great job of capturing or doing anything with your Pfas other than your anthracite and your filters, and it's going to be a problem for years to come. So, but yes, we have done it in other places, only at least 6 of them that I know of that were done in California.
More questions?
I have a question. What,
Sure.
You said you were in Orange County, California, and you're treating out a no DTEX.
Yes.
What was the influent concentration
It's
to begin
like
with?
20 to 30, so it's in the same range as what you guys are seeing. So it's very similar.
Okay, thanks.
Anyone else? Otherwise, thank you very much. Oh,
Part per trillion, just in case I was being clear.
thank you.
Terrific. Thank you very much.
Thank you. All right, we are now on to Geosyntec. Is there anyone on?
Hi, can you see me?
Oh, we can hear you now. We're sharing your
Okay,
presentation. Yes, thank you.
All right, good evening. My name is Jeff Tracy, and I'll be providing an introduction to Geosyntec and the proposed team to support the Wausau Waterworks for this project. I would like to thank all of you for the opportunity to present, and we appreciate your time this morning. The next slide. So Geosyntec at a glance. Geosyntec is a relatively small engineering company relative to those companies here tonight. We are 100% employee owned. We have approximately 1,800 employees across the globe with an office in Milwaukee and an office in Mequon, Wisconsin. We pride ourselves in our ability to be attentive to our clients while solving their most challenging problems. We are a practice-centered business, meaning we assemble the best internal team regardless of geography to support our clients, and we look forward to doing the same for Wausau. Next slide, please. Again, my name is Jeff Tracy. I'll be your point of contact should you select Geosyntec. I have 30 years of experience primarily in groundwater remediation, and I've spent my entire career in Wisconsin and understand the current status of Pfas regulations. I also manage the design and construction of a large Pfas-specific groundwater treatment system for an 8FFF manufacturer in Wisconsin. I also have relatives in Wausau, Tom and Mike Fisher, so I have a vested interest in this project. For those of you that just flinched, you were troublemakers in high school. Now, as I stated, Geosyntec is a practice-centered business, and the proposed team for the Wausau Waterworks project have completed multiple PFAS projects together. We are all members of the PFAS practice group in Geosyntec, and they are all part of this call, so you have a chance to meet them. The members include Balaji Seshasay, who is a PFAS water treatment expert with 10 years of experience. In the past 6 years, he's been designing and constructing PFAS treatment systems. Dr. Rula Deeb is a world-renowned PFAS expert involved in cutting-edge treatment technology research, stakeholder and regulator education, and she leads Geosyntec's company-wide PFAS practice group. Dr. Deeb spearheads our collaborative partnerships with dozens of universities related to PFAS research. Kirk Craig, who has been designing complex and large water treatment systems for close to 25 years, has also led Geosyntec's company-wide process and engineering design group for 5 years. Dr. Hamid Amini, who has 20 years experience in feasibility studies and design and construction of complex complex water treatment systems to remove emerging contaminants in drinking water and wastewater systems. And then Dr. Mary Ensch, who was unable to participate tonight, is an expert in PFAS destructive technologies and environmental permitting and sits in the Milwaukee office with me. Myself, Balaji, Rula, Kirk, and Mary are the core team that designed and are currently constructing the PFAS-specific water treatment system in Northeast Wisconsin. At this point, I'm going to turn it over to Kirk Craig to present our qualifications.
Thanks, Jeff. If you want to advance to the next slide, and can you guys hear me okay?
Yes, thank you.
So as Jeff alluded to in our earlier slide, Geosyntec is internationally known for our technology leadership, our broad experience, and really exceptional client service. In fact, we've been the leader in emerging contaminants and associated treatment for over 30 years and have been on the forefront of PFAS-related technology for over 10 years. We have over 100 PFAS projects and really close to 10 treatment projects. I personally work on 3 treatment projects, 1 potable water one, and 5 big federal PFAS investigations that will be hopefully transferring to ERAs soon. We are, as Jeff pointed out, the only firm with experience designing and constructing a treatment system specifically for PFAS in Wisconsin that was approved by the DNR. And then we're also local. We have local expertise and a solid understanding as a result of this in PFAS regulatory drivers in Wisconsin and around the country. Also, I want to point out our focus is really on industrial support, despite our substantial influence on the regulations. We've done so in Wisconsin, and we're also able to, because of this, to be impartially advocate on behalf of our private clients and our municipal clients when it comes to dealing with regulatory agencies. Next slide. And just jump right to the next one again. So yeah, as I pointed out, we're also one of the few consultants with design experience with regard to PFAS in drinking water. And again, we're the only consultant in Wisconsin that has received DNR approval for PFAS-specific groundwater treatment. We did this project, and we'll showcase it later, this design and construction project also in a phased approach, a very expedited construction process. We received really unprecedented permit approval too, a permit strategy that will help our client avoid NOVs. PFAS, since it's such a wily contaminant, really needs to contemplate these types of strategies. And you know, this experience enables us to serve as an owner's rep. We do that often. We provide advice on very complex drinking water systems around the country for our clients and deal with stakeholders and regulatory agencies, and this includes PFAS experience. We also have a lot of DOD and DOE grant money. It's SERDEP and ESTCP grants, and this is in regard to the removal and destruction of PFAS in wastewater and in biosolids. We have experienced groundwater modelers and risk assessors that have specifically worked on the fate and transport of PFAS. Also, in addition to those DOE and DOD grants, Geosyntec actually invests millions of its own dollars to fund our own PFAS destruction technology research. And we team with tens of universities and think tanks to help develop these destruction technologies and optimize treatment technologies. And the whole purpose of this is to help ensure that our clients not only are using the most cutting edge technologies, but the intent is to help them reduce their long-term operating costs and the waste management costs, as many people have talked about. And we have firsthand experience that, that's where the money is really going to be. That's the carbon and resin usage. So to make sure the technologies are there to reduce that long-term is very important. Next slide. So here are a couple examples. The one on top is a real-time picture of the construction that's being done at the Wisconsin project. And for this project, Geosyntec started out doing treatment technology evaluations. Balaji will chime in later with respect to our relationships with all of these vendors. We then moved on to bench scale testing. A lot of focus, which Balaji can expand on too, on Wisconsin-specific pre-treatment, right, to optimize system performance and carbon usage. Then we went on and did an expedited treatment system design, got cutting edge and regulatory permit approvals, and like I mentioned, permits that are actually favorable to our client with respect to NOVs. And now we moved on to the system construction. I can say firsthand that it was a challenge getting the system built so fast during these past few years with all the supply chain issues, but we really came up with really proactive strategies to help our client avoid and navigate through those supply chain issues. And then as part of that project too, we have a lot of firsthand interaction, not only with the city council, with regulatory agencies, but we do a lot of interfaces with stakeholders, and even I help them interface directly with the general public. Another project that I also worked on, and also our other project team members, is the bottom project here. This is a municipal drinking water system design in New England. We helped out with the permitting and design and constructed this system in 4 months. This is a site where the city was down like 60% of their water, so it was imperative that they get this system up by within a 4-month period before the summer months hit. So we helped out with the regulatory negotiations there, and that PFAS, that treatment is actually, that system is actually treating the water to less than 2 parts per trillion, which is below the laboratory detection limit. I think the influent concentrations of that system are even as high as 182 parts per trillion. Next slide. So in summary, as it pointed out, Geosyntec has experience designing and constructing very high-profile PFAS treatment systems in Wisconsin. We have a proven track record of implementing very effective and low-cost solutions with respect to PFAS. We have experts in PFAS management strategies and treatment technologies and continue to push the envelope with respect to these technologies. We have a broad understanding of the PFAS big picture, and that includes the regulatory strategies, where the regulatory environment is going, risk assessments, and making sure that our clients stay in compliance. And then we have extensive experience, as we've pointed out, completing similar scopes of work, delivering cost-effective solutions, very fast-paced, and state-driven projects related to PFAS. And with that, I'll go ahead and turn it over to Baji, and he can talk a little bit more about what we've done here in Wisconsin and our experience with pre-treatment.
Sure. So as has been previously brought up, there's a lot of concern about the life cycle costs and optimization of the treatment system and pre-treatment. The Wisconsin project that we're currently constructing is an excellent example of exactly that aspect that we focused on. So that particular project had similar issues of high iron and manganese, as well as TOC, that was all going to have a significant impact on the PFAS removal, as well as the ongoing media, GAC and ion exchange media costs. What we did was look at bench scale tests and rapid small scale column testing for both Gac and ion exchange, optimize the pre-treatment in order to significantly reduce the iron and manganese, as well as drop out the TOC. We specifically selected GAC media GAC that is suitable for TOC removal upfront before PFAS removal subsequently, along with ion exchange polishing. All of this led to our final design that we project to significantly reduce the overall media usage, the changeout frequency. We also went one step ahead and developed the site-specific changeout criteria for how we change out the carbon and the ion exchange, and this is done in order to maximize the carbon and ion exchange media usage and reduce the lifetime cost, life cycle cost, as well as the changeout frequencies. We closely partner with the leading carbon and ion exchange suppliers, including the ones that are being contemplated by City of Wausau, and we have existing ongoing relationships with the carbon suppliers for reactivation of spent media, as well as with the ion exchange vendors on regeneration of regenerable resin. We've also worked with other single-use ion exchange resin vendors and have successfully implemented that not only here in Wisconsin, but also in other states such as California and North Carolina as well.
And that's it. You know, advance to the next slide if you guys have any
Sure.
questions.
All right, are there any questions? Mr. Force.
You mentioned pre-treatment, but I didn't gather that you were removing PFAS as the pre-treatment target. It seemed like your pre-treatment discussion was to reduce the iron and manganese and the TOCs ahead of PFAS removal, and maybe I'm confused on that.
Yeah, I'll take a shot at that first, Baji, and then you can chime in. You're right about that. That's where our pre-treatment is, because our actually implemented pre-treatment technologies. But we are working on and have license to, and our own even proprietary technologies that are actually intended to remove a significant amount of PFAS as a tree treatment process. Again, they're all kind of cutting-edge technologies, and we hope that they'll, come to market soon. Balaji, is there anything you want to add on that?
Hamid, go ahead.
Hamid?
Yeah, and I wanted to mention on that specific project,
We just lost audio for you.
You just muted yourself.
I think you muted yourself. Or maybe, yeah, there we go.
All right, can you hear me now?
Yes.
Yeah.
Apologies for that. On that specific project, the purpose of the pretreatments was to remove the iron manganese before it hits the PFAS removal vessel, because you don't want the capacity of the ion exchange to be consumed, the PFAS to be consumed with iron manganese. So we do the pretreatment process, remove the other, if you would call them noise constituents, and then leave the ion exchange PFAS treatment specifically to focus on that. And then the effluent would, you would have the removed iron manganese, but also a non-detect on the PFAS.
Mr. Forsyth.
And then a correlative question. Did I miss it, or did you discuss residuals disposal options?
I can briefly touch on that. So we have a few different ways we deal with it. So as I mentioned, we've successfully implemented reactivation strategies at other sites, working with the carbon suppliers for spent carbon. And what we do is use what's called custom reactivation. So, carbon from a particular site goes to the reactivation facility and gets reactivated, and the same carbon comes back to the site. So it's a custom react. It doesn't get mixed in with the entire pool of reactivated carbon. We've also worked with ECT2 on evaluating regeneration of the resin. And like others have mentioned, we try to optimize the treatment system performance to reduce the overall concentrated waste stream, and then we're also involved in a plethora of destructive technology research for destruction of any concentrated waste and any other non-regenerable media waste.
Thank you. Any other questions?
Real quick, which community did you work in the municipal water supply for? Can you share that?
You're on mute.
Unfortunately, we can. I can tell you that it was in Massachusetts. Yeah. That is a problem with a lot of our projects. We can't really talk about them, but.
Okay, thank you very much. Right, it looks like we have one left. AECom, or is that what you go by?
Yeah,
Perfect.
AECom, you're spot on. The PowerPoint came up. This is lovely. Before I get started, I missed.
You think that right now?
It's working. All right,
Okay,
so far
perfect.
so good.
Thank you.
All right, so thank you so much for allowing us to come today, or allowing me to come today to talk a little bit about AECom's PFAS treatment experience. And I wanted to introduce our team. And this is the same team that's serving Madison Unit Well 15 for their treatment process. We're also supporting the village of Weston with their PFAS issues right now. And so to introduce myself, my name is Angel Jabo. I live in Stevens Point. I've been with AECom 20 years, working in the Stevens Point office, and I specialize in drinking water for 20 years. In AECom, I serve as our emerging contaminant leader along with 7 other individuals, including Chris Curran. I also serve as a groundwater expert for drinking water treatment. Lynette, who's also up on the list, she is also in Wisconsin. She's a professional geologist, and she specializes in the state. She's been serving as sitting in on the PFAS regulatory boards happening at DNR level, and getting to know a little bit more about the regulatory environment, making sure that we're involved and understand what's happening, both in drinking water as well as remediation, as well as wastewater, and throughout all the exciting regulatory world. Next up is, I should mention that Lynette also knows a lot about the sampling experience. Weston had a question on why their 2014 results were so much lower than their current results, and she was able to look up information and provide that. So that's the type of support she can provide rather quickly. Francisco up there, he is our treatability expert at our Austin labs, and he runs the lab there that does treatability studies. Currently, he just put the schedule in for Weston for their treatability study, and he's now doing, I think, 5 currently on his plan for the next few months. Francisco is been with AECOM for, I believe, 9 years, and he has been doing a number of RSSCTs with GAC, as well as ion exchange, novel sorbents, and a bunch of interesting researchy sort of things that he gets to do in his lab, as well as real-world information that we need to be able to do our designs. Chris Curran is probably our PFAS expert that we would go to first for some of our PFAS-specific questions on actual treatment and construction. He is our expert for North America for PFAS, done over a dozen water treatment-specific plants for drinking water. And he sits in Philadelphia. I work with him on the emerging contaminants group, so I work fairly closely with him on a couple of things. He also, we're working together on a project for Ann Arbor where there's a couple different contaminants that we're looking at there. Namble Lee up on our list. She is a recent hire for AECOM. She's been with us for 6 months. She previously worked for Purolite, which is an ion exchange manufacturer. So last Friday, we were talking with DNR about bench testing and kind of what we need to do, what some of their questions might be. And one DNR person asked, well, what about NDMA in ion exchange media? And I said, well, I know that's one of the reasons why we have to flush to waste at the beginning, waste so much bed volumes, but I didn't know exactly how much. I asked Namble. 4 hours later, technical report, ready to go, all the answers I needed to give back to DNR. So she's a great resource for us. She even provided a little anecdote about her work at Purolite doing some of that same research. So it's always fun to have those sorts of technical experts that you can lean on when you have questions. Besides those people specific, those people reach out to even more people. So in Wisconsin alone, we have a PFAS initiative team. There's 20 of us that actually work in Wisconsin, and we meet monthly to go over what's going on in our state. We also send emails around regularly saying, hey, did you see this new PFAS something or another coming out? Did you see this public announcement that happened? And we try to keep each other engaged in the activity in our state. There's also a global team. So the global team's over 200 people. Most of them are in North America and Australia. And we also have regular meetings. We use a communications platform. Email's not quite as good, but there's another platform that I can send a request out and have 200 people have an opportunity to respond. And so we have this opportunity to access this great network of amazing skill sets that cross a wide range. One interesting item that also came up, that's kind of that email off to the side there, you can kind of see. We had a question from Madison of, well, how about disposal? We just heard that this might become a regulated waste. What do we do? Okay, send the question out. Within 24 hours, I had 5 responses, very technically savvy people who are providing their input into this exact question. This is an example response, probably the best one we had. Pulled the top part of it. He went through the exact regulatory environment, what's going on, what AECOM's doing. The person who responded in AECOM is actually responsible for disposal of our own waste that we generate as operators of some plants for remediation sites. He provided information on specific ways that they do landfill selection, as well as ways that they try to reduce their waste to make sure they don't create anything that they don't have to. A little more about our PFAS expertise. This is our U.S. expertise. We've been doing this for over 20 years, many hundreds of project sites. I would say the PFAS samples continue to grow by quite quickly. For Michigan alone, we tested all of their drinking water sites, and a large number, I should say, all their public drinking water sites, as well as many of their wastewater sites as part of a program with a regulatory agency. We also have a number of sites in Wisconsin, not drinking water, but related to PFAS and PFAS treatment and regulations. So our PFAS experience ranges a very large area from site investigation, remediation, source discovery, and then continuing on to risk analysis, and then treatment. And then also we do have some experience in destruction with a defluoro technology that is ongoing. So some specific sites. This one's interesting because it is 9 wells, and they do treat at the various well sites. They do have various raw water concerns. They have iron and manganese removal, softening, and then of course disinfection. The interesting thing about these sites was each of them had a different PFAS concentration. They all needed different GAC media lives. So we looked at ways to reduce the life cycle cost by managing some of the changeouts. AECOM does have very good relationships with vendors, and also sometimes ends up working with them for changeout frequencies, as well as a long-term cost strategies to make sure we can reduce costs for our clients. The next project in New Jersey has 5 extraction wells. This one's also very interesting, another challenging raw water source with iron and pH issues, as well as VOCs. In this case, there was pH treatment to avoid water quality issues. This is just another, there we go. One item that happened was the operators had decided to turn off the pH treatment after startup. That resulted in fouling of the GAC. AECOM prides ourselves in our design of making sure that we will look at the water quality and make sure it's stable so you don't end up with water quality issues. Making sure water quality is stable coming into the process and then leaving the process is pretty critical so that you don't end up with these sorts of problems. So pH treatment, of course, here you can see that it was necessary, and when they turned it off, there was problems. Continuing on to Massachusetts case study, the interesting one about this is that we look to use existing equipment. The existing equipment was horizontal pressure filters. Unfortunately, they were not usable because of the distribution issues with trying to get the right distribution and making sure that we're going to get good quality performance. And so they ended up doing an expansion for that project. Again, just some costs available to you so you can look and see some of the history at some other sites. For New Jersey, this project had 5 wells that were coming to a single port, a single source. The interesting thing about this project that I wanted to bring up is they started with ion exchange treatment as the emergency treatment process because they didn't have time to get GAC vessels in there and get GAC installed. Now, they're not going to stick with ion exchange long-term because the cost for ion exchange long-term is much more expensive. Ion exchange media is very expensive to replace, and the GAC is a lot less. So they did a very significant alternatives analysis. So they looked at both cost, which would be capital as well as life cycle cost analysis, as well as other what we call non-cost factors, including constructability and I believe plant operations, process operations. Part of the alternative process and what you can set up for alternatives, examples would be that equipment sizes are kind of set. So if you have 2 pieces of equipment that were going to solve your problem, well, what happens if you go up a size? Or if you had a third one? Do you get better performance? How much better performance? And is that better performance worth the additional cost? Those are the types of things that we'd like to look at with our alternatives analysis. Is there some sort of benefit to perhaps increasing those sizes just a bit as far as long-term performance? Perhaps you can treat if PFAS was to increase. Perhaps you have some more room for that in the future if you look at that and plan for it. But maybe the cost makes it that's not worth it. So you get that information up front so you can make an educated decision on what you want to do. Another example project is Braintree, Massachusetts. Braintree was in a similar boat. They were about ready to build a plant, had some of it there, and found out they had PFAS. What did they do? So they actually looked at a novel absorbent called cyclopyr that they could put in the front and then pull out within the dissolved air flotation, the DAF process. Also looked at absorption in their GAC filters and then side stream processes, and are currently under review. That has not been fully finished yet, but that is some of the different processes they have chosen to look at. This is our list of PFAS water treatment experience. You'll notice all the potable ones listed, so you can see the number of projects that we have. I know Chris has been involved in at least a dozen, and some of the other folks, I know Tim White and a few other folks in AECOM have been involved in the others. This is a list of Wisconsin PFAS projects. I should mention there is no treatment-specific projects as far as like treating drinking water. There's nothing there like for that. But there are a number of projects for things like dewatering management for PFAS contaminated water, as well as remediation reviews, looking at sites and site evaluations. Past 2 years, so specifically for me, these are my potable water clients I've had in the past 2 years. That's up there just so you can understand that we're engaged in the industry in Wisconsin, and that we understand drinking water and the regulatory environment with DNR, PSC, and whatnot. So this is in here just for questions if you have any. So there is information in there if you have any on pilot testing. But continuing on to concerns and mitigations. Looking at the regulatory environment, Lynette is, like I said, been paying a lot of good attention to that and trying to look at your crystal ball and make some plans. And so what we like to do is make sure that we're paying attention to health-based objectives as well as regulatory limits, and setting our objectives and goals so that we can be well within those limits, usually 75% if we can of those limits. So we have some space to go. Funding, we are aware of the Safe Drinking Water Loan Program as well as other funding mechanisms and the timeframes associated with that. Also aware of the American-made materials requirements that go with that funding, and that may limit some of your options if you're looking for funding for that equipment. Scheduling issues, we are aware that there's a challenge getting GAC tanks right now. Pre-procurement's been critical for a lot of our clients in trying to meet schedules. Also, making sure that you're involved with your regulatory agencies early is helpful for your schedule. Ultimate disposal, I mentioned that earlier. Community and perception, we are very active in participating and promoting community engagement with our communities that we work with, and we have a lot of options that we can provide our clients to help them with their community engagement, whether it's providing information for them to process or actually providing a platform or going through a number of different options to get that community engagement and perception variable mitigated. And last, as I've mentioned previously, is decision modeling and making sure you have a good multivariable decision analysis. And so this is an example of a triple bottom line where you have technical, social, environmental compared against your life cycle as well as your O&M costs as well as your capital improvement costs. Another example decision model if you want to get a few more background items in there. And then just to mention, we know that you have a time frame for submittals, alternatives analysis, and decision matrix items are noted. So then just wanted to mention again our support. We do have the communications plan, and we do recognize, just kind of following up at the end, we have a lot of great national leaders that we can research and we can add to, we can reach out to and bring to bear on our projects. And with that, I say thank you and see if you have any questions.
Thank you very much. Any questions? Yeah, Mr. Force.
The defluoro processor product that you mentioned, is that an exchange resin?
No, unfortunately
what
not.
Is that? What is that?
Oh, well, let me see if I can go back here. So defluoro is Okay, so some people talk about destruction and products. So defluoro is what I call kind of like a plating process where you take two plates, you put electricity to them, and you basically electrocharge that water, and it actually takes those carbon fluoride bonds and breaks them apart. Very, very energy intensive. And so what we do for that, that'd be for like landfill leachate, or if you were to regenerate an ion exchange resin, you really concentrate it down, you'd use that technology. I bring it up because some people are interested in knowing that that's available. And that is some of the research directions things are going. But really, it's not applicable for these sorts of projects. Ion exchange resin, you're looking at, a number of products that are already out there. But defluoro would be more for the other side of things of taking care of a very concentrated waste stream.
Anyone else?
Is that the same as the cyclopore that
Oh,
you
no,
were
the
talking
Cyclopure,
about?
that's a good question. The Cyclopure, there's a couple of novel sorbents out there that are available that we've tested in our testing lab. And let's see if I can get back to that slide here. Probably won't be able to.
Do you know which one it is?
Try 32. Oh, I'm off by one. I think it's one more. That's the defluoro technology. There we go. So there we go. Novel sorbents. We have modified bentonite, commercial cyclodextrin, and a graphene suspension. And then there's the new cyclodextrins. We have a couple of. We're doing one study, I think, in the next bit. Not sure if it's on that. But those are different novel sorbents that are available that we can test in our treatability lab and look at their how they perform.
All right, anyone else? Okay, I'm not hearing any more questions. Thank you very much. Now, for this commission and the public, we do have an opportunity to go into closed session if we'd like to. We don't have to, but maybe I would offer a quick break for us. I know that I could use a quick, maybe less than 10-minute break, but quick break. So, without any objection, okay. We're gonna take a quick break and then we'll come back and decide what we're doing next. Thanks.